Yeah, I guess if you do it enough, you never forget it. I was forgetting some of the Excel. I was forgetting. Oh, you mean you mean designing or the using tools and designing layout? Well, okay.
We did a handful of standard cells.
The layout stuff is easier. I mean, for me, I guess I've done it for the last 20 years. So, but learning Virtuoso, I forgot some of the accelerator keys already, right? I mean, but it would just take me about 10 minutes to learn again. Yeah, you learn. You guys can craft that. What did I give you? I give you. You can craft the accelerator stuff. Is it in the .ill file or is it in the? I think it's in the CDS environment file. Maybe in both. Anyway, as you get better, you want to craft some of the keys to do acceleration. Okay, so today I want to make sure everyone is moving along. I think Alan is probably now, he was actually working with Tom to get set up in there, so I think he was having some trouble with Red Hat. And if he can't get it working on his laptop, I think he's already set up a mechanism. I'm surprised he doesn't complain to me about the mentor stuff, because you'll need to have that, we'll need to have that installed for that system in there to be useful. So at this point, everyone is up and running, has cadence running, and is working on layout, right? So what do you want me to do? My plan today was actually just give you sort of a quick tutorial on Composer, right? Which is the schematic tool that you'll use in concert with Virtuoso. And it's actually a lot easier to learn because it's just schematic, right? But there are a few caveats or nuances or whatever you want to call them. I use what's called inherited power and ground connections. And I do that because, well, when I was on sabbatical, that's what they did. And they said, we need this because we have multiple power domains. And then when I came back, I just continued to use it. But it actually comes in useful when you're building chips because you may choose to connect everything to the same power rail, right? And it by default will let you do that, right? But the inherited connection allows you to actually connect a hierarchy of cells to a local power grid and then assign at the top level, assign a different connection to that power grid to a pad. So you can actually bring in a separate power rail to different places in the design. And you're doing research experiments and you're doing stuff maybe for your own advisors. It may be handy for you to be able to measure power of a particular functional unit, right? Which makes, even if you power them up with the same voltage, if you have them going out through separate pins, it makes it real easy to then get power measurement. So setting aside the whys, that creates a few special operations that you have to do. The easiest way to deal with the inherited connection, all the library cells I gave you use them. And so you'll have to continue to use them too. You can't just do VDD because the synthesis tool will have a fit. And the easiest way is just to copy like the VDD and ground pin from layouts that I have right into your layouts as you create them. Right, and this of course permeates. If you design something by hand with these cells, the parent will also have to be labeled with the inherited connection. So the format is it's just something that actually is very useful and was never available in other tools like, I don't know if Aletta had it, but Magic certainly did. You'd have to give it a different name, and then you'd have to like connect them together at the top. So the inherited connection does what? It by default connects to VDD bang and ground bang, and it if you want to connect that particular subdomain to something else, you then would then connect, instead of connecting it to the VDD, the top level VDD bang and ground bang nodes, you could connect it to whatever the name was. It will inherit, that connection will inherit and propagate through all the elements that are connected below that in the children, I should say. So it makes it a little easier, to do this And I think it's also something that can be like synthesized automatically. So you can actually just tell the tool when it does synthesis that you want these various groups of cells to be connected to different power rail. But I think the syntax, can you read the syntax to me, what that node actually looks like?
Wow.
So there's a layout pin. This is it's called inherited connections. So you inherit the name of, for the actual name from the parent. That's what the inherited means. So for the layout pin, it's, is it brackets? What?
Yeah, brackets at
Brackets at,
for ground GRND colon
right. Oh,
percentile.
What's that?
Colon and then percentile.
Oh, percent sign?
Yeah.
Yeah,
And
yeah.
then colon.
Okay, that's right.
Yeah. GND.
GMD.
Bang.
Okay.
Yeah.
So this is what it looks like. To create it, have you guys created a pin? Do you know how to create a pin? Do you know how to create a pin?
Yeah, create.
Pins are a little tricky in Virtuoso.
Yeah, like
Like if you want to create your own pin, you know how to do that?
created from here. From
Let me show you how to create your own pin. You guys, you can copy them, and that'll work, of course, as long as. I'm going to show you how to create a regular pin, and then I'll talk to you about how to do the inherited, how the Virtuoso set up to do the inherited stuff. It's actually is this going to come back? Hello, thank you. All right, let me just go ahead and create a new cell view, make it a layout, and test. Okay. You say I want to do a pin over this. Oh, I just drew right there. Still thinking about something. I don't know if the network is slow or what the deal is, but anyway. I'm just gonna draw a piece of metal here. And then if I want to create a pin, I go to create pin. Okay, and why is this thing keep changing? present layers don't necessarily going to work. So they stored tech layers. Where's the rest of my layers? So they showing drawing layers for some reason.
Uncheck that valid. On
Where
the
do you
top.
oh, you mean this guy?
Routing.
Oh. We'll display the terminal. And then in here, there should be something called label. That's why it's easier to like copy it from somewhere else.
No, label the option was under create.
No, no, no.
LPL is the label.
What's that?
LPL.
LBL, you see it?
Yes.
I missed it.
M1_2 LPL. Pin LPL.
Oh, so that's right. Now I'm remembering. So it's metal, right? LBL, right? So you want that as the label, and then you have to have the pin selected over here, and you give it a name. Leave the strong. It's a rectangle. I think that's it. And so now if you click, you can drag, and then if it works, oh, that's the other option. Then I tend to like to put this right in the middle, but then the font size. So the label actually is something that you can select separately. Okay, I think I just hit it there. The Q. And where's the font size? That's the
No,
pen.
you have to.
Yeah.
Didn't do that.
I haven't done that. There it is. It's kind of weird. You see when that thing turns like white? The middle of that pin turns white. Then you've selected the label. And hopefully we get to set the font here. Yeah, we do. 1 is like really huge. So you have to like use 0.1, for example.
0.07.
Is that what you're using? 0.7. Okay. Yeah, you make it something that's reasonable. This is kind of tricky. So you see how I did that?
No.
Well, you're being honest at least. Okay, so I'll delete it. Ah. So I just like to hit Q and then keep clicking until you get the pin. And once you get the pin, you can delete it.
So you have to do both the metal one and the metal one pin on top of each other, both, or?
Right, so the metal one doesn't play a role. So you
Okay.
want metal one pin and metal one label, LBL.
Okay.
Those are the two layers that you need both.
But you have a rectangle just of metal one, like
Yeah.
a metal one drawing layer as well.
Yeah. So presumably you have something that's already in your layout that
Okay.
that you want to now add a pin to.
Okay, gotcha.
Yeah, I'm just in fact, you can draw a pin over anything, but I mean, it's not going to register unless it overlaps. A metal one pin is only going to like associate that name with that metal one if it touches it in some way.
Right.
I just guarantee, like I said, precision, right? I make sure my pin is perfectly positioned and centered over whatever it is that I happen to be drawing over. So create pin. Okay, so you bring up the menu, and then you want to make sure pin is selected as the drawing layer, right? Because when you actually click and create that X, it's going to draw in that layer, right? Which is this layer purpose pair they call it, right? It's a metal one pin. Okay, and so you add your name up here, and there's usually a direction. I can't find it. Oh yeah. So it's in out by default. So you're gonna, you have to play with this. You can always edit it. I'll show you how to do that. Let's say that this is an input pin. You got to mark it as input.
Mm-hmm.
Okay, and then give it a name, right? And then go to this display name option, and it remembered it. But normally this is not set properly, and so you have to choose the LBL, right, for the metal layer that you're drawing for. Some of them use just generic, like, label. IBM's PDK has an LBL for every pin, layer purpose pin pair, right? And you'll see the variation here. And sometimes it's just, you just have an LBL in the layer menu over here that you would actually use. But you want to use this one for this PDK. And then you want to make sure it's visible somewhere. We click that. Oh, there's the height. Okay. So you can check the height. I thought I missed this somewhere. Don't use 1. It makes really big labels. So you want to do 0.7 or 0.1 or 0.07, something in that range. That makes it reasonable. By default is 1. Leave the stick thingy. Drafting. I guess the visibility's in the parent here somewhere. Yeah, it's right here. So really just the font size, and just make sure this is set to LBL, and you're done. Okay, if you screw up the font size, you can fix it. If you screw up the LBL, you can't. I don't think you can. Okay, and then make sure display terminal name is turned on. And then you're almost ready. So you got the input, you got the name, you got the display terminal, you got this layer selected, and you've got the proper LBL layer selected inside the display terminal name option. Now you're ready to click and then drag. Okay, and you drag the pin over, and then you want to put this guy as close to the middle as possible. Okay, and it's kind of weird the way Virtuoso works, but it puts this dotted rectangle around the shape. If you click on it, if you do Q, you can tell which, when you got things that are like superimposed in the Z axis, which is the axis you can't, see. You can select different items just by continuing to click, and then keep this Q menu up, properties menu. And then when you get to the pin, you'll see it. You won't be able to get to this guy unless you actually get, so there's, as soon as you move over, you'll see that it puts a smaller rectangle or a bigger rectangle, depending on how big the font is. And then it highlights that X in the middle. That means that now you're going to edit this text label component. So I guess you can change it. Sorry, I didn't think you could. So it looks like you can. If you happen to choose the wrong thing there, you can actually change it now. Okay, and then the height as well. Okay? So what else? If we go back to the pin, again, it's usually the second click for whatever reason. And then call it, so tell me, you got an inherited one?
Yes.
Property, no. Yeah. So you go to the connectivity, and you put this net expression in. So when you look at the inherited VDD and ground, it'll be the exact same process, except that this guy will say VDD bang in the net name, and then the net expression will actually be, what is it, at?
Yes.
So it's part of this, right?
Yes.
So it's, what's that?
Languages.
Maybe I should just bring one up here too. Just take a look at it so I get it right. You guys can see it. Cancel layout. And then we'll zoom in here, and then click this guy. Q, TP. I'll have my click. Right. So the name goes in. The terminal name can only be edited here, and you do ground bang. Okay. If you want to make this inherited, you go to the connectivity thingy, and then the net name will show up here, and then you type this net expression, which is what I use, GRND, right? And the default is, if you don't override it, is GND bang. So this allows you now to, of course, establish a different power domain. That's all there is to it in layout. It's just under the connectivity menu. Notice this is an in-out. VDD and grounds are in-out. Okay, unlike terminals, right, for the cells. Make sure you get those right. Caliber may complain about it, actually, if you don't do them right. They may give you an LBS error. Okay, so we're done with pins. That's one of the trickiest things. Everyone got it?
It's not working for me.
Well, I guess you won't be able to create any pins this time. What if it's not working for you? What isn't working?
Nothing appearing here.
Nothing appears.
The menus are not the same actually. So I got that create pin.
Yeah.
Here's the pin A.
Yeah.
Create label
Create-
options. Operate also.
That brings that up. So layer name.
Yeah.
So this alpha's not right.
Okay.
Yeah, it's metal one for sure. They changed this and this is the newer version, really?
Yeah.
Oh,
It's different.
Jesus.
Okay.
Layer purpose, what's under that? Just label?
Label this label.
Yeah, they made it kind of easier. Okay, I agree. So that's what you want. You want metal one, the
Okay.
purpose is label.
And M1 is selected.
No, you need one M1 pin.
M1 pin. Okay.
Right, yeah, that's a common mistake. So now you can click and drag. Yeah, there it goes. Yeah. And then you can put your, well, you made that font tiny. Okay. Got it?
Okay.
And then you can increase the font if you want. Just move over that little A, yeah, and hit Q, and change it. Oh, you just made a big piece of metal, that's all.
Yeah.
Okay, whatever. Okay, so what else? Do you guys, what else do you need to know here? I mean, everyone knows how to run the caliber menu. Everyone's got that work. What you do?
I have it up here, I don't know how to run it.
Oh, so, right, yeah, so bring up the inverter from the standard cell library because, you know, everyone do this. Because I want everyone to get what's called get a run set, you know, for at least for DRC and LVS. All run set is a set of parameters that you've tuned. So let's see, if I run DRC, this is ZIB, this is actually a PDK menu that allows you to do various things. You just want to hit OK. For standard cell designs, it's already set up properly. So just click OK on it. When we get to, if we get to chip level, we'll have to change a few things. But there it is. Okay. And so when I think what it'll ask you initially is whether you want to run a load of run set. If you don't have one, you just hit cancel. Okay. And so the problem is that it defaults to mostly good things. The one thing it will not have is the rules, right? Because it doesn't know where the IBM PDK is. There's probably a way to set this in an environment variable, but the easiest thing to do is just click the rules. Anything that's red is in caliber is bad. Okay, that means you have something that's not going to work. And so you click the rules and then do the browse, and then you can actually then go out to your IBM PDK directory, right? Because you got to point this to the rules that IBM has for this technology. So in my case, it's user local IBM P stays in there, PDK. And then I think you can hit enter and then just keep selecting it. So you can just, you know, navigate out there to caliber, DRC, and then for DRC and LVS, there's only one file that you can choose as a backup here, just ignore it. Right, it's this drc.cal, which is the DRC deck for caliber. So you click that, and then it turns green, and then it's going to be happy. So the only other thing that you typically change, I've played with all kinds of things here because when you have different reasons to do things, you have, you know, other options, and Caliber's done a real nice job. The only other thing you have to make sure of is that you export from the layout viewer, right, it's gonna create a file that it's then going to use to check against the rules that IBM has set up, right? And so you don't, so you got two choices. Either you can point to a file, the file being that inverter x1.calibre.db. That's what it's going to create if you have that thing checked. If you already have one and you want to just check it, then you can click off the export, but you never do that, right? Always export your data from your layout, right? GDS2 is okay, the top is blah, blah, blah. The rest of this is fine. You can just hit okay, and it'll do the export, and then it comes up with this window of death. So it's a window with gobs of information that will take you a year to parse through. And in general, you don't need to look at all the debug output, right? You know, unless you have problems. But most of your problems can be solved actually just from this DRC results window, okay? And the results by default are going to show all the rules that were applied and checked. And a lot of these actually aren't even relevant to the cell that you're checking. But it'll give you a green check if either it wasn't applicable or it passed, right? And so it's quite a list. There's 2,070 checks that it makes. And it does it very fast, okay? And all these are the design rules associated with this technology. If you don't have any problems, the easiest way to decide that is just to look for the 0, right? So if this is marked with something other than 0, then you have a DRC violation. And you're like, well, where the heck is it? Well, it's in this list somewhere, right? And the easiest way to get to the problem is to just show unresolved. And since we don't have any DRC rules here, violations rather, then nothing shows up here. But if you did have one, then you would have, you know, that listed along with a red X. Okay, and then you'd have to look at that. DRCs are fairly straightforward to figure out what the problem is. You know, it's usually a spacing or a sizing violation, especially with diffusions. There's lots of rules with diffusions. Right, and then you can go to the layout and you have to fix it, and a half hour later you're ready to do it again. I mean, it depends on how bad the violation is.
Does it not point out the error where it?
Oh, so there is some cross probing that you can do. I guess should we create an error? I haven't. I mean, I just typically look at it. Let's see. I think it does actually. Yes. Will highlight. Yes. Did I hear yes?
Highlight result.
Okay, let's try maybe making this piece of poly. Create a poly violation. It's obviously a violation. Okay, so it's going to want to save this, and that's okay. I don't mind. For whatever reason, it doesn't like to do DRC checks unless. Then it opens up 3 windows, and of course the other 2 aren't useful. That useful at least. And so you have to restart it.
No, you can directly run it.
Can you?
Yeah. Ask to save.
Oh yeah, forces you to save it. Yeah, it's been modified.
What did you do to rerun it?
You just hit start DRC again.
Okay.
And it'll recognize that something's been changed. It's like a mini make inside of this thing. Okay, and now I got one. And you know, I usually put a frowny face on there. I think the LVS does the frowny face, but and then you can go here, show unresolved, and then if you click on it, let's see.
We have to click on the GR and then it'll show the option to highlight.
You need to bring the window up so you can see what's going on. Okay, you have to click on what?
No. When you click on that one, and then at the bottom,
you double click it, and it goes right to where the violation is. It puts these 2 bars up. You can do it the hard way, Venkata's way, or the easy way, my way. Or you can always take the highway. Okay. So if you double click on it, it tells you, it gives you yellow bars, and it tells you. And the highlighting, I don't think goes away, but I think I think this button up here will clear it. Oh, this zooms in. This zooms into the various. Oh no, this just scrolls through the various violations. See that? See, it scrolls, and I think this will turn them off. Change the color. I don't know. It looks like it changed the color to me. You guys can play around with it. I mean, the point is that, you'll get good at this. This part of it, VLSI isn't, DRC is not too bad. LVS is what kills students, keeps them up all night. Okay, everyone got the hang of it? Okay. That's pretty much all you need to worry about in terms of this tool. Well, it tells you down here, right, a minimum space and notch. It tells you what the actual rule is. It helps to memorize some of that. So I'm going to go ahead and fix this problem. Actually, it would be, I don't think you can do an LVS unless you're DRC clean. So I'll just go ahead and you can save by just going to the file menu and save. Okay. Oops. Okay, and so now what we want to do is cover a little bit of Composer. So you can't run LVS until you have a schematic. So let's go to schematic. Right, you can create this just like you create a view for layout. You can just choose schematic. And it goes through the licensing crap. Okay, now I'm giving you schematics, and the best way to to create a schematic is to copy one. But if you wanted to create a new one for whatever reason, you can go to File, New, and then we can do Test, and then you just choose schematic. Okay. Apparently there's one that already exists. I'm going to blast it. Okay, and so you end up with this blank screen. You go, well, what do I do? Well, you want to create an instance, usually first, and then go to Add Instance, right? And then click on the Library Browse button, and then of course, don't go to your library. Go to IBM's library, and then go to FET. And then the two devices you're going to use are NFET and PFET. That's pretty much it. I don't want anyone using any of these specialized devices, which costs extra. Usually. Some of them are free, but some of them cost extra. Okay, and then it brings up this big monster menu, right? And you typically just I just typically don't try to configure anything there. I just come over here, and let's see. So you can see that it has something that I didn't do. Oh, by the way, I forgot to show you in the DRC. We'll do it when we do the LVS. You want to, once you get it pointed to the right file, then you want to save the run set as. And then just something locally in your Cadence IBM 9RF directory. I create a directory called Caliber, and I have my 3 run sets in there. They really, most of that's being stored is just the path out to the IBM file. There are some other options, especially for XRC for extraction and things that, I have several run sets for XRC because I want to do different extractions for different reasons. So I just screwed something up here. Let me try doing it again. Instance. What did you do? Oh, do I have to give it a name? What am I forgetting to do here?
I think you have to give it a view.
Oh, yeah, that's the problem.
Schematics.
Yeah. You can't click here. Yeah, I'm forgetting things. Yeah, you have to choose a symbol.
Yeah.
Right. So anytime that you bring things into a schematic, it always comes in as a symbol. And you'll see that when you create hierarchical designs, after you create a schematic, you'll automatically generate a symbol. I'll show you how to do that. And then now you can use that schematic as a component in a parent in a hierarchical design. And then when you create an instance of it, it'll use the symbol that's created, okay? I'll show you the symbol creator. It's kind of cool. Anyway. All right, so then there's the end. And then you can click it, and is it Q here? No, it's not Q here. They changed the menu for this. So if you... What is the
I thought it was
properties? What?
Q.
No, it's not Q. Q brings up.
No.
Oh,
these
Scroll
are
down
the-
and you can get to everything.
Oh, that's right. It is Q. Okay, never mind. Right, and then you can set the size. Remember, your size in your schematic is got to match your layout. This is the most common place where LVS will complain. If you forget to change the size, change the layout, make the transistor a 1x and go to a 2x, forget to change the size in the schematic, it'll it'll tell you that, complain about it, right? And the sizes, the length you never change, and then the default width is, where
It's
is
down
it?
at the bottom, I
Down at the
think.
bottom, yeah, W is 120 is minimum. It's minimum size, this is a minimum size device, 100 by 120. And there's finger options and things like that. I recommend that you not use the finger options. I don't think, yeah, you probably don't want to use them. Just make the device, if you have to, in your layout, if you have to create like a wrap, right, don't worry about it. Just make this, you know, always keep one finger here. So the only thing you'll change here, my point is the only thing you'll change is the width for the most part. Yeah, pretty much.
And we just make them match the size of the transistors you have in the
For the
inverters.
layout.
Okay.
Right, and so 1X for me isn't 120. I didn't use minimum size devices. What is it? You guys gotta memorize.
It's 200, I think.
200.
200, 360, then 780.
Oh. Always trying for some extra points here. What's the P size?
P sizes, they are 360, I guess. 360, 70, no,
900.
480,
480, 900.
480, 900 is 1.2.
What's that?
480 and 900 is 1.2. I don't know what 4 is.
480, 900.
Yes, and 1.8.
1.8, yeah. Okay, yeah, that's it. Anyway, but just make sure you do it. Okay, so what else here? I mean, the rest of this is pretty easy. Just type W for wiring, right? And it gets kind of, you know, draw your wires. Don't forget when you create your, so pins. So let's see, create a pin. Same kind of deal, except it's a little easier. A lot easier actually. Okay, so for most pins, it'll just be the pin name, and then make sure you set the direction. Okay, and then the direction you'll know that if the direction's wrong, this thing will point in the wrong way, in the wrong direction.
Yeah, I don't
Make
know.
sure you click when you start the wire right in the center of the pin. Okay, of course LVS will catch this if you screw it up. But if you want to do one of those inherited connections, so if I draw a wire up here and then do create pin, I think you can do like G and D bang, and then attach net expression, and then default name is GND bang, and then the property name is GRND. Is that it?
Yeah, no, the whole.
And then I'm going to make it an input output. And then if you get lucky, you can click right on it there. So something will look right. I think
Yeah,
it's right
property.
though.
Shift key.
Maybe, I don't think, yes, I think I added something that wasn't necessary. Let me check this again. Cancel, delete,
Shift
create,
key.
pin.
Shift key.
Yeah, I think you just fill this in down here. So when you do the attach net expression, so either you give it a name up here, or you click attach net expression, and then you give the property name GRND, and then GND bang is the default name. I think that's right. And then input output. Or maybe it's not going to take that. So you do have to put GND here. So why did it repeat it? That's what?
For all your designs, it looks
Did it?
like that.
Oh,
That
does it?
worked for me.
Yeah.
Okay. I don't know why it doesn't look right to me, but okay. I think that's it. This is the right format for sure.
The same format?
I just don't remember seeing it repeated there. So you're saying that's true in the inverter? I already have that. Here's my schematic. Yeah, you're right. I'm losing my mind. Never mind. Okay. And so, you know, you can check the sizes. Yeah, 200 and 480. Right, so obviously that's the size of the 1X inverter. Okay, so let's see. Let's try, I don't know if I can do something without having this thing at least partially valid. And connecting ground. And you can move this stuff around. The keys are kind of awkward. Oh, and you know, so it's really important that you have these options set properly. Otherwise, you'll go nuts. Let's see. Cancel. I think it's under. Yeah. Make this, please make sure that the spacing set to 0.125 and the snap is set to 0.0625.
They are default.
Is that the default?
Yeah.
Oh, that must have been in my CDS environment file, which is great. Yeah, don't change those. You create a nightmare. Those seem to work pretty well after experimenting things for a while. What do you do to create a symbol here? I want to overwrite my symbol. Create another instance. And if you memorize these, you can just type the name in. Again, it's like Windows, it wants to try to guess what you're trying to do, and it's always wrong. Stretch. And don't forget to connect your substrates. And then you can play with the sizes. But for the symbol, okay, so once you have this, then you can create a symbol automatically. So you gotta let's see. It is under create. It's under
cell view
create.
from cell view, yeah.
Yeah, create cell view from cell view. Oops. Okay, don't forget where this is at, or you look around for half an hour before you find it. Create cell view from cell view. Hit OK, and then it'll give the from name schematic to name symbol. I'm gonna replace it. I must have. Right, and then before you hit the go button here, you know, pay attention to where these are, because it saves some work. And the defaults are usually good, but sometimes it gets it wrong. If you've done your inputs and outputs correctly, you'll want to put the inputs on the left, the outputs on the right, and then of course, the pins, it'll make them both at the top, right? VDD bang, ground bang. I think that's good for this guy. And then you get this box, and then now you're gonna have to use like do a little creative design here. These guys, I tend to like move them to the, you know, the tool needs them for simulation and stuff, so I just like to get them out of the way. Because you know, the two that you want to pay attention to are these two. And you can move these guys, let's see. So what's an inverter look like? So you can go to, when you draw lines, where's the line thingy? Okay. And then we want to put a bubble. Oops. Oh, you click and then you drag. It's very strange. And then I think you can move it up with Control, Alt, Function. Move this guy. I thought there was like a key that you could use to like move it a pixel at a time. And Connie, you're an expert at this stuff, right? There it is. Okay. If you've done that, if you left those like 0.0625 and 0.125, right, those are important here too. Because remember, you're going to be connecting wires, you know, to the pins on this guy. You'll see that we're going to move the pins up here in a second. And if you don't have them on the grid, then you'll go crazy, because when you go back to schematic and create an instance and this symbol gets popped into your schematic, you'll try to get your wire over there and it'll never give you the ability to connect to the pin, right? So you just make sure, again, just make sure your display options are set to these values. It creates a real pain if you don't do it. I'm just trying to give you a fair warning. So let's move these guys up. Let's see, how do I do this? So obviously we're going to move this out here. And then we're going to move this out here. And then we want to create a wire. Is that what I did, Venkata? We'll take a look at the one I did for the inverter in a minute. But you just use the same schematic commands. You just do the M for move, and then you can draw wires. They're not wires, they're actually just graphical symbols in this case. I think you double click to end it. And then again, don't delete these, just move them up. That CDS name is the name of the cell. That'll show inverter 1X, or in this case, it'll show test. Okay, and then once you have that, these guys you can just get rid of. Right, and then the other thing I'd like to set is the origin. Because if this guy doesn't, there's an origin here. I think it's right here, 0, 0. I think it tells you somewhere. But if it doesn't, you can go, well, I want to create my own origin. So this is important because you really, when you bring this in to a parent, you don't discover this until you actually use it. When you bring it into a parent and you go create an instance of this element that I just made, if the pin, the A pin in this case is not at 0, 0, it'll, you know, your cursor will be here and then your graphic will be over here, and then you'll have to do one of these thingies. And it just makes it cumbersome and ridiculous. Where's create origin? Let's see, option. Edit? Yeah, origin. And then just click on that guy. Oops. I don't know why it moved it. It should have moved. Oh, and I forgot to move the A out. I don't remember whether I put that there or here. I think I put it back here. Oh, I keep it inside the cell. That's what I do. Pins are out, and then the names are in. There it is. Shazam! Inverter. All right, and then I think try to close it. Ask if you want to save it, hit yes. And so now if I want to now, let's say that I want to create an instance of, I don't know, can I do it inside of this guy? Probably not. Let's try create instance. And then instead of going to the IBM library now, you're going to go to your library. Test. Somewhere QRST. Did I create that? Where did I create that guy? How about I didn't put it in the IBM library? Yeah, that's the unfortunate part about having a big library. Let's just choose something like one of these guys. Or 1X. Okay, and so when you're in Composer and you do a create instance, oh, I forgot to move the. Oh, this is another glitch. This is like a. You're like, where's my VDD and ground connections? Okay, so you guys see how you create the instance? It's just like you do any other instance. You got to create instance, and then you can choose the library, and it'll bring the symbol in. And since, you know, I have the origin set right there, you know, when I brought it in, the cursor was sitting right there, which makes it nice whenever you're positioning it. So you actually have to do this twice to get those inherited connections. I don't know why, but once you have created it, then you go back to same thing, create cell view from cell view, and then you hit OK, and it's going to say that it already exists. In this case, I just want to modify it, right? And then say yes, and then all of a sudden the VDD, the inherited connections show up. Then it tells you that it added these, which I have no desire to keep around. Right, now you can actually then move these guys up to where they need to be. And I think you have to select everything. So don't forget that. You'll have to, you know, and I usually put them up at the top somewhere. Then you gotta, you know, fiddle around with this, the sizing and stuff. You know, use mine as examples, okay? But you'll have to do it twice, otherwise you won't get the VDD and ground inherited connections, and you need to have those. You won't wire to them for the most part. If I show you something that is built with some standard cells here next, I'll show you that the default connections are VDD and VDD bang, ground bang, and if you don't wire anything to them, I don't think you need to. Let me just double check twice. So we'll save that. This guy, close that. So let's see if we have a function here. Yeah. Okay, so I'm in this case I have a a function that I just, just consists of, 4 2-input NOR gates and then, whatever it is here. A couple inverters, decoder, right? And so this is the other, NOR 2x2 that I'm using, in this higher level design. So this is a higher, and so none of the VDD and grounds are connected. And all you need to do is create the pins, right, for VDD and ground here. And then you don't have to actually connect them because it knows that these unconnected pins are going to refer to, the default values are going to refer to these 2 pins. Okay? So your PDK has examples of everything you might want to do. Schematic is actually fairly easy.
So when I create a pin here, I don't
What?
get this. When I create a pin,
These pins?
yeah.
Yeah, you just create pin,
Yes.
right? And then you need, remember this is, the VDD and grounds are special, so you type GDD, or in this case, GND bang here, and then click the attached net expression, then GRND there, and then GND bang here. I think if you click on an existing one and do Q, do you get those properties? And it shows you something weird. I don't know. Never understood why they give you certain things. Not very consistent. I thought there was something other than Q you had to hit to get.
You have to go into one of those expand menus from within the query there.
Oh, you do?
Yeah, so hit Q, and then go scroll down and hit expand on pin and net, and it'll show you more detail about names and everything.
Right. Interesting. Okay. But I think there's also a edit
You want to create this one?
properties. I don't remember if there was a shortcut for this. Let's see it. Stretch. Properties. Right. It gives you a better view. This is what I liked it for it to pop up, but it doesn't. You have to actually go to
Shift Q,
properties.
apparently.
Oh, is it Shift U?
Shift Q.
Oh, Q. Yeah, that's it. Shift Q. Oh, you saw the shortcut in the menu. Yeah. So you hit the Shift Q, and then you get this. This is actually a little nicer, but okay. Like I said, schematic's pretty easy. LVS.
So can we go back to the inverter?
Yeah. So we're going to go back to the inverter and do an LVS now.
Yeah, I have a question.
Yeah.
No, not the schematic.
Oh shoot, we're out of time. What's that?
The schematic.
Oh, the schematic for the inverter? Okay.
Did you create that symbol for the inverter?
Oh, I did.
Yeah, from where?
Oh, so you just do create from cell view, right? And then, okay, and I don't want to change it, so I'm just going to hit modify.
Okay.
I'm supposed to bring it up.
Okay, it's okay.
Right. Yeah, practice it a couple times. You don't want to forget that this is how you do this. I don't know why it's not bringing it up. Let's drop it for now. I just want to, let me give you a quick, because you guys are going to be using LVS because, to get these cells built, you'll have to caliber, LVS, and then the same thing, hit OK. And you can do the same thing. I actually have, like I said, run sets, and I keep them in calibers menu or subdirectory. And one of the only things it does is just populates the rules with the rules file, and the rules file is actually very similar. It's just the lvs.cal. You just go to the LVS directory. Okay. When you get to PEX, it gets a little. There's some options that we have to talk about, but we're not going to do simulation yet. And then here, you just want to export from schematic, right? Make sure that that's set. And I think there's a schematic view, that list, also export from schematic viewer. So what you want to do is you want to take your layout, create this model that it uses internally. It gives it this source.net file, right? I'm sorry, it takes the schematic, create this source.net file, take the layout, create this DB file, and then it does a formal verification of the two. So make sure they're both exported. And hit OK. This one will pass, of course, I hope. Oh, do we want to move this class back to 4? Or is that, Don, is that something you can do, or
Yeah.
you prefer not to?
I prefer 5, but I can do 4.
Okay, you prefer 5? Is anybody like insistent on 5 or
No,
4 would be great.
4 is better.
4 is better?
Yeah.
4 for everyone is better? So Alan's not here. I think he also said probably 4. I don't want to, get you in trouble though. I mean, because I know you have to work.
I can do 4. I just need to shift my schedule around a little bit. It's not bad. It's
4
what I did last semester, so
You did 4 last term?
yeah, the host class was at 4.
Oh, you're right. Yeah. I guess I have a slight preference to 4 as well. And
Okay, then.
you okay with that?
Yeah, I missed something in LBS. It's not running
Oh.
right or something.
Oh, you mean when you brought up the run set?
Yeah,
Sorry.
it just said like it wasn't the correct formatted file or something.
Right, okay, so
I
I had a run set and I cheated. So let me close this again and run LBS.
I
Without
just did
the
it a
run set.
second time and it actually went okay.
Oh,
I must
second
have missed
time?
Something, yeah.
Okay. If I hit cancel here, I have this, and then we know how to go get the rules. Like I said, the only thing you have to pay attention to here is make sure that these 2 buttons are clicked. See, this one is not by default clicked, and so you actually have to check it. And that list is, for whatever reason, not exported from the schematic. And then we gotta select the rules again. Oh, I gotta turn that feature. They might not turn off the mouse pad. I cannot stand it. I think everything will be green at this point. So, I mean, I'm just illustrating that those are really the only options that you have to click to make this work. So I'm just starting with a new run set. And bada bing, and you get the smiley face. Or you get a frowny face. LBS is kind of tricky, so we're over, but the kinds of things you want to look for is to make sure that Caliber is really pretty good compared to Assura. So it tells you how many ports in the layout in the source, how many nets and instances. Obviously, if the number of objects is different, you're going to fail. Okay? Most times you fail because of wiring issues, right? You got something that's wired incorrectly in the layout. And if you start flipping wires, there's really no way to teach this. You actually have to go through it yourself, right? It will give you more detail at the bottom here and it usually gives you pretty good clues on what's screwed up. It'll tell you what net is inconsistent between the layout and the schematic. And that's, I assume that you can design a schematic properly. I mean, if you, just be careful in your schematic because you're really doing schematic to make sure you do the layout right. So if you don't do the schematic right, then you're really in trouble, right? So make sure your schematic is right. It's supposed to be a higher level abstraction and it gives you a higher level view of what it is, the electrical connectivity and so on. Common things are, if you forgot to tie the bulks down in the schematic, that'll give you a violation, right? It's usually pretty good at telling you where the problems are. You can go there directly, fix them. Sometimes, as I said, when you do like D flip-flop, things get more complicated. It gets a little hairier. And you certainly, the worst case scenarios are the ones where you got, like macros that have problems. And then they get kind of difficult. But if you do all your standard cells correctly, the tool is responsible for constructing the schematic and the layout, right, for the macros. And if you've done a good job in the standard cell library, I've never had any issues with violations. Okay, well, that's enough to chew on for today. And so today's Wednesday, so we make this lab due a week from today? Yeah? Everyone be able to handle that?
What is the lab?
What lab?
Yeah.
The lab that's on the website. It says Lab 1.
Okay.
Probably has the wrong date because I didn't know how long it would take us to get all the tools and stuff. All right, week from today. So work hard. You owe me 6 cells. 1x, 2x, 4x, AOs and OAs. And some of you have, I think the layout's done already for like the OA or the AO.
I'm starting, but I have some questions I want to ask.
Okay.
Just about running the tools.
Okay. All right, the rest of everyone else is excused. We're done for today.
I have a question on one of your layouts.
You do? Okay.
AO.
My AO, I don't have an AO.
You have
Not yet.
You have an AOI though.
I have an AOI.
Yeah.
The AOIs are harder because I had to size, as you can probably see, I have to
Yeah.
size all the internals. Do you want me to bring up an AOI
AOI 1x. X1, yeah, this one. The
layout?
layout.
Okay.
So why is your inverter, the P transistor here, is not 1x?
This guy?
Yeah.
It's not 1x?
No.
It should be 2x, right?
And your infit is 1x.
So you're saying I screwed this up? So the N is definitely 1x.
Yeah, the N is 1x.
So this should have been something that was 480?
480, yeah, exactly.
Well, there's a mix of ends. There's a 1N and a 2N.
It's just 3 inputs, right?
Yeah, it's only 3 inputs, so
Yeah. What am I thinking? There's no inverter here,
Yeah.
right? So, right. So the series ends down here have to be, so this is the 1x. These are in series, so they're 2x, right?
yeah.
That makes 1x.
1x in parallel with 1x.
And then these guys are in parallel with,
another parallel.
right. Let's see. So the output node's here. So the current flows from here through this guy and then through this guy and out, right?
Yeah.
And then this is connected. So this has to be,
Everything
Yeah,
in the
2x,
P is
2x.
2x. All the paths in the P network
Yeah.
are
So you
2
just-
transistors.
right. So if you trace through the electrical paths, right, you're going through 2 devices to get to the output in every case, right? So 1 and then 2, then 1 and then up and around and then 2, right? And so because that makes 2 series Ps, right? I mean, from a schematic, the easiest thing to do is just look at the schematic, right? Because, schematic should tells all. Right. So we got these 2 parallel paths, which means that you have to do 2x to get 1x.
Okay.
Right, and then on the output, this is a single path from the output to ground, so that's a 1x device. And then we have these 2 in series, which makes, so, remember, anytime you go series, you have to then double the length, double the width to get the equivalent X power drive strength. Got it? No?
Where is the inverter?
There's no inverter here, it's an AOI, so you can't use this one.
It's AOI.
And or invert.
It's
I-
naturally inverting.
It's naturally inverting.
Yeah.
I did the hard ones. Because, like I said, this is a monolithic cell, there's no inverter here. It's naturally inverting, right? And so now I got the entire
Yeah.
guts driving the output, and so I have to play these games with the sizing.
So
You
for
guys
the-
get
for the
the
AOs, then we do everything internally,
In 1 or 2x,
1 or 2x.
Yeah, choose-
But, okay, gotcha.
choose your poison. I would
Right,
probably
right.
do 2x, but I would probably do 2x. When I got guts that aren't driving an output, I tend to do 2x internally. Although I will cheat and do a 1x something or other. Remember, you're not driving an output node, so you just gotta make it reasonably fast internally. So you have some flexibility. It's only the output node that actually you have to pay attention to, making sure that it's, because the tool is gonna depend on having various drive strengths in order to size up or down depending on how much fan out it has. It's gonna do all that automatically.
So for 4x AO, is it better to make the AOI 2x and then the inverter 4x?
Yeah, I would create one set of guts, and I would use them on all 3 designs and use 3 different size inverters.
Okay.
You can do everything internally as 1x, right? That is valid, and it's just gonna be a little slower. I would probably make it 2 because you're going through, you're actually going through an inverter to speed it up a little bit.
Okay. So we can make 2x and then use it across all.
Yeah, you use the 2x in the 1x, 2x, and 4x designs. You just change the inverter size. Like I said, you guys got the easy one. I'm surprised I didn't add it. I mean, it was an obvious thing to do, and it would have been easy to do, but I didn't. And I've noticed the tools actually make use of it in some FPGA designs we're doing. Okay, then you had a question, Don?
Yeah.
All right, everyone else is done.
Question.